one, less than 1, integer exponent. So let's just start with the basics. Then you have x to the y. There are two pieces there. There's the x and there's the y. Let's start with the easy one. What's the y? It's the exponent. Very good. The y is the exponent, and that would make the x the what? What is the x?
The number.
Coefficient.
No, there's a better word. It is a variable, but that's not what we're calling it right now. If there's a b, what's the b? A base. We call it a base. We call it a base. And that's going to be important today because we're going to be talking about like bases and unlike bases and what the difference is and how the exponent property is applied to one. So how would you describe the rule that's occurring right now? So how would you describe that? Somebody's looking at that, they see x to y, they have a kind of understanding what an exponent is. How would you describe to them what they should do? How would you describe to them what they should do? Go ahead, Medina. What should they do? Yeah, it's like, someone sees that, how would you describe it to them? Good. Yeah, no, that's good. There you go. Exactly right. Yeah, that's exactly what we do. All right? We want to take x and multiply x by itself as many times as y said. Right? That's what he said. Yeah. All right. These are necessary things we have to write down. There's expanded form and there's exponential form. So, what does it mean to expand? Just generally, yes. Yeah. Right, so generally expansion, right, you're getting bigger. So, as Caleb said, x times x times x times x. And then what would the exponential form underneath that be? Exponential. Right, so there's expanded form and exponential form. Those are kind of these different ways that we can represent the same type of expression. So x times x times x times x is expanded form, x to the fourth is exponential. My assumption is in the lower grades where you get exponents, you do a lot with like expanded form. Like you would write it all out, count up how many x's you had, and then plot it back in the exponential form. What we're going to go over today are the properties that exist that allow us to not have to go through and expand it, put it all together, and then compress it back in. We can just do these operations. Does anyone need more time on this first slide? We have 7 properties to talk about today. Let's start easy with the first one. The names are important. You need to know the names. You'll be asked about the names. So to be clear, you'll be asked about the names. You'll be asked to identify what property you're using. So you need to know that it's the zero power property. The zero power property is the easiest one because all it says is take anything to the zero power and it equals 1. So literally anything to the zero power equals 1. So let's go through a couple examples so we're all on the same page. I could have a number like 1,789,463,001. X to the 17th, all to the 0, what would equal? Would equal 1. Very good. What about Mr. Smiley to the 0 would equal? 1. Anything to the 0 is 1. No matter what you have, anything to the 0 is 1. And we're going to explore later on why that's the case. You're actually going to be asked for that tomorrow. Try and figure out why anything to the 0 power is 1. Yes, sir. 0 to the 0 power is 1. And we're going to talk about why. Even negative numbers? Yes. You would never take 0 to the 0 power. The negative, no, 0 can't be negative. It's not positive either. Neutral. What would that be? N? That's an N, it's an extra letter on it. What else? When you do, a lot of you might be in chemistry either this year or next year, when we talk about electrons and protons and neutrons, right? There are 3 things in an atom. Right? You have electron, proton, and neutron. Electrons have a negative sign on them. Protons have a positive sign. Neutrons have neutral. That's a lot of neutral. Now, the really hard one. If I can have your attention, please. We're on to the next. The negative power property. For whatever reason, students find this one to be the hardest one. It shouldn't be. Please make sure you're taking notes. The negative power property. Negative power. Question or answer? Nope, that was a good one. Alright, the negative power property, this is what it states. It states that when you have a negative exponent, so not a negative coefficient, a negative exponent, not negative base, a negative exponent. The base moves to the denominator, and the exponent is now positive. The base moves to the denominator, and the exponent. What we're going to say about this is we're going to say that we hop the line and switch the sign. So if you're one of those people that kind of need these little jingles in your head to remember things, you hop the line, you can pretend like this is a fraction, you hop the line, and you switch the sign on the exponent. Yeah. Is it about this? Yeah? Sure, it's just a way to represent. No, it's a way to represent. So like, for instance, let's say you had 2 to the negative 3, so that equals 1 over 2 to the third, which equals 1/8. Those are all equivalent things. Well, it was something that they had to develop so they could make it useful in mathematics. They needed that in mathematics. So we need a way to represent this. So we can represent it like this. And then we want a way to be able to not have it in the denominator. So we're like, oh, let's make it negative. A lot of math, and we're going to talk about that a lot this year, we got to a situation where we needed to keep doing math, so we created something so we can keep doing math. All right? We get to a point where math stops us. So mathematically, we can keep doing what we're doing, but we're no longer, it's like taking the square root of a negative number. You can take the square root of a negative number. You can. There's a negative side though. We have to do something with that negative side. We'll talk about that later. What we do, because we can do it mathematically. So if we can do it mathematically, there must be something for us to do. Let's take a look at these two examples up there in purple. Example number 1, 5 to the negative 2. Example number 2, z squared over x to the negative 3. Yes. Let's do 2 examples and carry it. Right. Here's our first example. This is 5 to the negative 2. We're going to pretend like it's over 1, just to kind of give us a line underneath. It's 5 to the negative 2 over 1. So what's going to happen is the base is going to come down here, and the exponent is going to come positive. So what's left on top? 1. Anytime that you have an integer that's being raised to an exponent, and it's the 4th power or below, we're going to want you to multiply it. So anything above 5, don't worry about it. But so in this case, our most simplified answer is going to be 1 over 10. Yeah. In this next problem, we have z squared over x to the negative 3. So once again, we want to apply the negative power property, which says give a negative exponent. You're going to move it in the denominator, get it in the numerator. So you get x to the third. And then where is z squared going to go? Is it going to go in the numerator, or is it going to go in the denominator? Those are 2 options. Think about it for a second. Is it going to go in the numerator, or is it going to go into the denominator? Fine. Numerator. Adriana, where do you think it's going to go? Denominator. James? I saw your name. Anybody else want to get in this? Is the z squared Is it going to move down to the denominator, or is it going to stay in the numerator? It is going to stay on top in the numerator. It's positive, right. It has no negative exponent on it, so don't move it. It didn't do anything to you, don't do anything to it. Alright? So it didn't do anything, so leave it up there. I have 2 for you to try with your partner. 7 to the negative third, and x squared over 2 to the negative 3. Want to take 2 minutes? Let's get started. Pilot 5, yes. It doesn't matter where you go. I'm listening to you. What's up? I'm listening to you. I'm listening to you. Yeah, I'm just looking at my paper. What's up? You want to try to figure out what it's going to be? We'll talk about it. Thank you. If I can have your attention, please, thank you. Volunteer. What'd you get? 7 to negative 3. For 20 people. Okay. Okay. And what is 7 to the third? That's lazy on me now. That's below 5. You got to multiply. How should you multiply that? What? 3 is below 5. Oh, no. 3 is below 5. 3 is below 5. You get a second one? No? It is. 7 to the third is 343. And Richard, you were giving us the answer for the second one. What do you got? 2 to the third. The next thing, what is 2 to the third? 2 times 2 times 2. Good. Great. Okay. Someone tell me, if someone has 6x squared, what did they do? If someone has 6x squared, what did they do? Question? Yeah, they just multiply the base times the exponent. Instead of doing the rule, the very fundamental rule, of taking the base and multiply by itself, times the exponent. So we have 6 of those. Questions on the negative power? Yes, ma'am. No, they're both negative. What would you do? You flip them. So if it was a negative on top and a negative on bottom, they flip. So if 2 negatives on top, they come down. 2 negatives on bottom, they go up. A positive and negative, just bring the negatives up. Just like that. Okay, the next couple here, we're just going to kind of blaze through. It's pretty easy. What we're going to call this the product property. I'm going to refer to it that way as the product property. And all the product property sets, when you have like bases and you're multiplying them, you add x. So if you are, so the answer? What's the question? We'll get to that one. That's one of the properties. Did you have a question, Carol, or an answer? Elijah, question or answer? What's up? So the rule is when you have like bases and they're being multiplied, you add the exponents together. When you have like bases, and you're multiplying, you add the bases together. So in this case, I have 4 to the third times 4 squared. So first off, they are like bases, they're the same base. So they're being multiplied. So what are you going to do? You're going to add them. So what is it? What? 16 to the fifth. All you do is add the exponent. That's 4 to the fifth. I know you were. I was having trouble not crushing it. I felt bad. Need them? No, they're not right. Okay. Just write it down. Just write it down. I'll try and take them as many times as I can. So, x to the 5th times x to the 11th. You can probably do it in your head. Robbie, what is x to the 5th times x to the 11th? X to the 16th. X. Like bases, add it. So, the opposite of that is going to be what? When you're dividing, you subtract. That's called the quotient sign. Quotient sign. You can't do anything with it. X squared over y squared. That's it. Can't do anything with it. If they're next to each other, you can multiply. Sure. They're going to be divided. So, what you'll notice here, we have 5 to the 7th over 5 to the 3rd. So what you're going to do is you're going to do 5 to the 7 minus 3. And I'm aware that most of you probably will not have to write 7 minus 3. But that's okay if you do. That gives you 5 to the 4th, which is the same thing as 25 squared, which is 600. 5 to the 4th and 25 squared. Right. So the only thing to keep in mind here is that the remainder, or the, right, so whatever you get here, this 4 goes in the numerator. So keep that in mind as you work on these two. This one's a harder one. This one's kind of a sneaky one. Alright? 2 minutes. Go ahead and get 2 answers. Two minutes, get 2 answers. Okay, what's up? Did you write it down? So what's the quotient? Yeah, one basis will be the one basis will be divided. Then use the exponent. So here you go 5 to the 3rd. 5 to the 2nd. So 5 to the 2nd minus 2. So 5 to the 3rd. 5. Okay, if I can have your attention, please, thank you. Okay, I'll take a volunteer for either one. Volunteer for either one. Chris, this one. What do you got? One. Can you kind of walk me through this one? then minus 13, that's why you do the top minus the bottom, is negative 2. So you set it to negative 2. And why did you stop right here? No, why did you stop this right here? Because it's not simplified. Lindsay, why is it simplified? You aren't allowed to have negative exponents. You can't have negative exponents. That's why things are going. You got 1 over from there. How about number 1? Again. Five x what? Y cubed. Why not squared? Very good. Because 4 minus 1 is 3, and 3 minus 2 is 1. But you don't have to have that. Yeah. All right. Let's talk about how she got that. I'm just going to kind of delete everything that's up here right now. I'm going to move this one. All right. If I have your attention, please. Make sure I have everybody with me. All right. If you're looking at this column right here, I'm just going to rewrite it slightly as 5 to the third over 5 squared, and then x to the fourth over x to the first. So that's just to kind of give me an idea where we're going. So now the quotient property says that when you have like bases that are being divided, you subtract the x. So I have 5 to the 3 minus 2, so this equals 5 to the 3 minus 2, x to the 4 minus 1. 3 minus 2 is 1, 4 minus 1 is 3, and we generally don't include the 1. So that is what we got there. The first thing. That's what that's about. So when you see like bases being divided, you subtract the x. I'm going to pick it up just a little bit. This one's probably the easiest one. A to the m to the n. A to the m to the n. This is what the Viva was thinking at earlier. A to the m to the n. It's called the power property. We'll probably call it the power property. How many levels deep are we? Then how many levels deep are we? You kind of said stuff. Great. All right. This one's pretty much the easiest one. So let's say you have something like 5 squared to the third. 5 squared to the third. So all you do, you distribute the 3 into the 2, and you multiply. 2 times 3. 2 times 3. So now you try x to the fourth to the sixth. 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 Madison, what is x to the fourth to the sixth? X to the fourth. I love mine. We're starting this base level, making sure everybody knows. Okay. All right, last two. These are applications of the power property. We're going to do the product. We're going to do the quotient. All right. So when you have unlike bases, I think someone was asking me earlier what unlike bases are. That means they're not the same, right? So A and B, those are unlike bases. Yeah. There's a product property and there's a power product property. The product property doesn't have an extra power to be raised. So you can see here the m just gets multiplied by the exponents that are on your chart. So for instance, I have 3 times 4 squared. So get 3 squared times 4 squared, which is 9 times 16, which is 144. Looking at that original expression, can someone get to 144 a different way? How'd you get 12 times 12? Okay.
3 times 4 is 12.
There you go, yeah. 3 times 4 is 12. And then you have 12 squared equals 144. And it better work out because math works that way, which is what's nice about it. Well, in this case, it works out because there's two things you can multiply. When you get like x times y, well, you can't do anything like that. You just left for that. But it's just nice to know, like, this is just showing you, like, oh, it works. Like, it's not Buddhist. You try and do a lot. 2 examples. 2x to the third, and 5 to the negative 2x to the 12, all to the 4th. Go ahead and work on those. Maybe a minute and a half. Fine. Yeah. Wait. What is about 30 seconds. If I could have your attention, please. All right, 2x cubed to the third. What'd you get? 2x cubed to the third. Yes. 8x to 9. You distributed this. You get 2 to the third. X to the 3 times 3. All right. Break it down into the steps for me for this one. So do it in 2 steps for me. Great. Five to the negative 8. Okay. And then you're not allowed to have negative exponents. So what do we do from here? Katie, what do you do from here? So we have, and where is the x to the 48 belong? The top or not? Does it have a negative exponent? So don't mess with it. What's up? Yeah. Yeah, what exponent is there if there's no exponent? If there's no exponent, there's actually a 1 there, right? So the 1 we can't see. So multiply the 3 times the 1. Yeah. Questions on this one? Last one. Power of a quotient. power, right? Power, meaning like the power right here is M. But again, power, right? That's M of a quotient, right? In dividing quotient. So you can see all that happens is the same thing that happened with the power of a product property. It just gets distributed. Let me think. X over 4 to the 7. And Adriana was just talking about what exponent is on both of those. There's a 1, thank you, there's a 1 right here and right here. So when we distribute this in, I get 1 times 7, that's 7. I get 1 times 7, that's also 7. The X is 7 portion. I got 2 good ones for you. Here, last 2 example problems. X to the third over 3y squared all to the third, and z squared over x to the negative 2. Yes, sir. What exponent on the x? Lindsay? What exponent on the x? Exponent 1. That's lower than what is 3. What is 3? 3 times 3. What? I mean, you'll always have access to the problem, like the name, but not to how they work. Yeah. Can I have your attention, please? Okay. I'm looking for your attention. All right. So, what mistake did this person make? Looking at that, I helped a couple of you with this. What mistake did this person make? There's a 1 on the 3. So 3 times 1 is 3. So your final answer is x to the 9th, 27, y to the 6th. Yeah. Think about the question, because it's probably important. Yeah. Please. Oh. Add it. Okay, what do you got? What's the balance? Of what? Questions on what happened there?